Hi everyone, it's Janine here, and in today's video we are going to be learning how to determine the Laplace transform of a function using the table method. So the Laplace transform takes a function of t and it transforms it into a function of s. And the Laplace transform has a really important property, and that is that the Laplace transform is a linear transformation. And so what this means is that the Laplace transform of alpha times f of t plus beta times g of t is equal to alpha times the Laplace transform of f of t plus beta times the Laplace transform of g of t. And so what this means is that just like with derivatives and integrals, we can take the constants out of the Laplace transform, and we can also take the Laplace transform of each term separately. And just a note regarding notation, we can write the Laplace transform of f of t as a capital F of s and the Laplace transform of g of t as a capital G of s. And we just do this to save time so that we don't have to write the curly L with the fancy brackets. And so let's go ahead and take a look at some examples. So let's go ahead and take a look at these examples here. So in this first example, we have f of t is equal to 5. So let's go ahead and take the Laplace transform. So we have the Laplace transform of 5, and we can rewrite this as the Laplace transform of 5 times 1. And from here, what we can do is we can pull this 5 outside of the Laplace transform because the Laplace transform is a linear transform. So we have 5 times the Laplace transform of 1. And so we can go to our table and determine what the Laplace transform of 1 is equal to, and we can see from our table that is equal to 1 over s. And so we have 5 times 1 over s. And so this is equal to 5 over s. And now let's go ahead and take a look at this example here. So we have f of t is equal to 3t squared. So let's go ahead and take the Laplace transform of 3t squared. And so let's start off by bringing this constant outside of our Laplace transform. And remember, we can do that because the Laplace transform is a linear transformation. So we have 3 times the Laplace transform of t squared. And we can determine what this is equal to using the Laplace transform of t to the n from our table. So let's go ahead and start off by identifying what n is equal to. So n is equal to 2. So using our table, we have 3 times n factorial over s to the n plus 1. So n is equal to 2. So we have 2 factorial over s to the 2 plus 1. And we know that 2 factorial is equal to 2, so we have 3 times 2 over s to the third power, and this simplifies down to 6 over s cubed. Okay, let's go ahead and take a look at this next example. So we have f of t is equal to cosine of 5t. So let's go ahead and take the Laplace transform. So we have the Laplace transform of cosine of 5t. And so let's go ahead and take a look at our table. So this is this case here. So we have the Laplace transform of cosine of kt is equal to s over s squared plus k squared, and we know that k is equal to 5. So plugging this in, we have s over s squared plus k squared, and so k is equal to 5, so we just have 5 squared. Okay, so simplifying this, we have s over s squared plus 25. And let's go ahead and take a look at a few more examples. In this next example here, we have f of t is equal to e to the 5t. So let's go ahead and take the Laplace transform of f of t. And so we have this case here. So the Laplace transform of something of the form e to the at is equal to 1 over s minus a. And here we know that a is equal to 5. So the Laplace transform of e to the 5t is equal to 1 over s minus 5. And in this last example here, we have f of t is equal to 3 times the hyperbolic sine of 2t. So let's go ahead and take the Laplace transform. So we have the Laplace transform of 3 times the hyperbolic sine of 2t. And because the Laplace transform is linear, we can go ahead and bring this constant term out of our Laplace transform, and we are left with 3 times the Laplace transform of the hyperbolic sine of 2t. And taking a look at our table, we have this case here. So the Laplace transform of something of the form hyperbolic sine of kt is equal to k over s squared minus k squared. So here we have k is equal to 2. And so we have 3 times k, so k is equal to 2 over s squared minus k squared, so minus 2 squared. And so this simplifies down to 6 over s squared minus 4. And that is our final answer. And so that is how you find the Laplace transform of a function using the table method. Thank you guys so much for watching, and I'll see you guys next time. Bye.